Hey, yeah, so I'm just gonna wait for another like 4 or 5 minutes, I guess, to see if anybody else shows up from lecture.
I'll ask a question now.
Yeah.
Okay.
So keep in mind we are being recorded. If you want me to mute, I can mute.
Um, so for the starter code for the same program,
Okay.
what is this uint 8?
So this is just think about it as like a kind of integer. You don't need to understand this code. So this is for writing and reading the file.
Yeah.
So like this is just has to do with the format of how it's written.
Okay, so like we just know that it's some type of thing, and then the raster is a pointer to that. Because then we have
Yeah.
to.
You kind of don't need anything, right? So the idea is that you interact with it with set pixel and get pixel.
Okay. Okay, so just ignore that. But this is like a type of thing that C knows.
It's an entity. Yeah, it's a type of entity.
Okay.
Yeah.
Okay. I was wondering
Yeah.
if that was something we said, but
No.
okay, cool. Thank you.
No, so like the idea at least is that you just interact with it with like get pixel, set pixel, save image, load image. So you don't really care about
Sounds good.
Yeah.
So would you be able to go through, like, write out your solution for one of the midterm questions?
Okay.
The last one.
Okay.
Questions.
Okay.
Okay, thank you.
What was Q6, if you remind me?
It's like the 20 mark one where we're reading the student number files.
Okay.
Yeah.
All right. So I guess we are doing so kind of as promised. So what I plan to do is to have a couple sessions that are basically doing, labs 7, 8, 9, 10. So we'll do 7 today. Okay. So first of all, so what's the idea here? The idea is we want to implement a queue. So Q would be first in, first out. And the idea would be that, like if you, so we can just think of it as an array that we keep adding to. And then if we add from the left, we also take out from the left, right? So if we push 5, push 6, push 10, and so on, then when we pop or DQ, we'll get 5 first, and then we'll get 6, and then we'll get 10, and so on. So the idea with the circular queue is that we have a fixed size array. So I'll do it maybe like this, right? And then what we do is we keep unqueuing like this, right? So maybe we unqueue 5, and then we unqueue 6, and then we unqueue 7. And then maybe we dequeue, and if we dequeue, that just means that we say, well, like this 5 is not there anymore. So it's going to be maybe like this. And then we keep unqueuing, so 8 would be next in line, and then 9 would be next in line. And the idea is that ordinarily we're not allowed to resize this list, then we're out of space. But with a circular queue, if we want to unqueue another thing, so maybe we want to unqueue 11, we'll just wrap around and unqueue over here. Okay, so in order to be able to do this kind of thing, we need to know where the queue starts and where the queue ends, right? Because this could mean any number of things, right? So this could mean that 11 is first in line, but actually what we mean is 6 is first in line, and then the last in line is actually 11. So the way the handout suggests handling it is keeping track of where the start is and where the end is. So that would look like this initially. Let me make it short. And then we'll say, okay, initially, this is the start. And this is also the end. And then if we unqueue, then we'll say, okay, so now the start is here and the end is here. And then if we unqueue again, then it's going to be that the start is still here, but the end is here. If we dequeue, what we'll do is we'll just advance the start. So we'll get the 5, which was first in line, and now it starts with 6. Make sense? And then if we unqueue again, so that would be 7. We unqueue again, so that would be 8. And then given that this was dequeued, we get to say, okay, let's say I unqueue 11 here, and then I'll just move and back over here. So now I'll know that if I start here, then I'll dequeue over here, then I'll dequeue over here, dequeue over here, and dequeue over here. Does that make sense in general? Okay. So, all right. So now let's implement this. So I'll start. Do you guys want so let's first do this that's not circular, just kind of as a review, right? So let me know if you're bored. So what this means is we have kind of data, which is initially the empty list. And what we'll do is we'll have functions that basically operate on this data, right? So we'll have a push. And the way that works is just like this, right? So far what this means is I can have a queue that's like this. And then if I say queue.push 11, what that would do is queue.data would become 11. And then if I push 15 here, then queue.data becomes 11:15, right? Does that make sense? So if you remember, the way it works is queue.push basically calls push, where the self is this queue, and then the value is 11. So in practice, what this is the same as queue.data.append 11. Make sense? So now we can also pop. So pop works like this. So this is just a thing in Python where if you say pop 0, that means get self.data at 0, remove it. Right, so this returns the value of data at 0, and it also removes it. And this is exactly what we want from a basic queue, right? What we want from a basic queue is we append on the right, and then we take elements from the left, right? So whatever's on the left is the thing that's first in line, so that should be removed. Is that okay? All right. So now we want circular cube. So the whole idea is that we'll have a fixed size, right? So we'll have like this many nuns. And we'll keep track of where the size is. And we'll have a start. And we'll have an end. Like this. And the way we'll do it is the start is going to be the real start. And then the end is going to be the index that's after the last one. So we know that if it's like from 0 to 0, in the same way that in Python lists, if you say like from 0 up to 0, that's nothing because the last index doesn't count. So we'll say self end 0 means that there's nothing there. Okay. So now we want push. So how do we do it? Well, so we know that end is where we want to put the next element, right? Because if you have, let's say, none, 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 and we start here. So if this is the start initially and this is the end initially, so the way it would work is we'll put something in here, advance the end. So the next time we put something in here, and then we advance the end again, right? So that means that all we need to do is just put this for here. And then we advance the end. So this is the thing that makes sense, but we'll start with just self and +1, right? So ordinarily what we do is we just advance the end one space to the right. The only thing is we sometimes want to wrap around. So we might be in a situation that's kind of like this, where this is the start and this is the end. And then we put something in here and we want to move the end back to 0 so that we can say, okay, it starts here and then it wraps around. So there is a trick to this. You can just say, you know, something like this. And that works. So you just say, well, like if end turned out to be equal to size, so that means it's like one index above what you can store, just set it back to 0. And that works. But you can also do it with a trick. You can say it's equal to self.end +1 mod the size. And that's the same thing. So if self.end +1 is smaller than self.size, then it's just self.end +1. If it's equal to self.size, then the thing mod itself is just 0, right? Because like 5 divided by 5 has 0 remainder. Make sense? So, okay. That is a circular cube. Does that make sense? Okay. All right. So, what do we want now? So now we want an str. So I'll do a wrapper instead. It's almost the same thing. So this is something that would work. So you can just take the array. But what I want is basically to output the list in the order in which it's supposed to be, right? So I'll do like results is like this. And then I'll start at start. And I'll go until I reach the end. And I'll append data I, and then I'll advance I by 1, except I'll wrap around to 0 if I get to the size. Okay, so this is basically like reading off the circular queue, except wrapping around. So now I want to represent it as a string, so I'll just convert the list to a string, which you can do with like str of res, right? So if you do something like this, this just gets you the list. Okay, so let's test it. So now if I just say print q, okay, so it's 11.5. So let me push something else. So I'll push 17. So now it's supposed to be 11, 15, 17. So, oops. Here, okay, so I guess here the issue is that self.end was 0. And when self.start and self.end are the same, we have an issue, right? So what we'll do is we'll say, something like this. So we'll count how many times we output, and we just go from self-start to self-end like this. I forgot to say count plus equals 1. Okay, so now it's like this. So the interesting part is if I dequeue, it's supposed to be 15, 17. Okay, so pop did not work. Oh, because I did not actually define pop. Okay, so to pop, we'll get the data at self.start. And we'll advance self-start by 1. And in the same way, we'll wrap around if we need to. Okay. So here we have 15, 17. I forgot to decrement the count. This, and in the same way here to increase the size. Sorry, not the size, the count, right? This would be number of elements. And here, number of elements would be greater or equal to 1. And here, the number of elements be minus equals 1. And here, this would be number of elements. Okay, does this make sense? So I keep track of the number of elements, and I print number of elements starting from self.start. So I could also take care of the situation where the push tries to push more than I can actually afford. So I can say if the number of elements is the same as the size, then I'll print is full, and I'll return. Because if the number of elements is the same as, if the number of elements is the same as the size, there's no way that they can add another one. I would be just overwriting an old element. So the handout asked for str, so I did wrapper so that I could just say print q. So what print q does is it just calls wrapper and it gets this. Okay, so yeah.
Yeah, I have a silly question about how classes work.
Okay.
So like for all of these like functions that you're defining in the class, like you're just saying, okay, there's this thing called in self called data, and then every other function in the class can access that and change it.
That's correct. So one way to think about it is really what you're doing here is you're calling like circular queue U11, right? So when I'm dot push. So when I'm calling push, what I'm like, this is basically like shorthand, right? So when I'm calling push, I'm passing this queue to self. So this is queue. So anytime I say like self.num elements inside here, it's the same as saying q, the lowercase q, dot push.
Okay, and you can just make them willy-nilly, like you can just be like, oh, this is what this is now, and everything's fine with it. Like,
yeah.
You can just say, okay, there's this thing called self.start.
So you can think about it like that, or you can think about it as I'm actually just passing q over here. Sorry, so this is confusing because this is code q, but so like let's say that this is like q1.
Yeah.
So like here I'm saying q1.push 11. What that means is I'm calling push, and this is q1, and this is 11.
And why do we do this as a class, not just like its own set of just a random set of functions?
So you could, it's just that this is nicer, right? So here I don't have to worry about, like, essentially like this does some of the error checking for me, right? So I don't have to worry whether like the push is the appropriate function because if there is a Q1.push, then it's the push that's associated with the correct Q1.
Got it. Thank you.
But yeah, like in totally, like when we do it in C, that's exactly what we do, right? So instead of because C doesn't have classes, so we basically just manually would pass Q1 to the push.
Right. Okay.
All right. So that's the circle Q. So what we want now is we want to sort them somehow, right? So suppose we would like to sort, so we want, so they would be sorted lexicographically. So this is, so basically we sort them as if they were lists, right? So how can we do this? So essentially what we need is because we can sort lists in Python, right? So if you have like L1 is like 5, 6, 10, and then L2 is 1, 2, we can just ask like is L1 before L2 or the other way? One way to see it is you can just sort them like this. Right. So one way to, so basically what we want is we want to do the same thing for queues. So if you remember, what we need to do in order to be able to sort two different queues is we need to have a less than operator defined for queues. So we'll do a function. Okay. So that would be LT. So what this is basically self is Q1 and other is Q2. And we want to return true if self is smaller than other in this sense, right? So one way to do it is to basically make use of the fact that you already can compare lists. So all that we need to do is just convert the queue that we have already to a list. And we've kind of done that here, except we've done it in order to print the queue, right? So what I'll do is I'll kind of copy paste this a little bit and reuse this. So that would be like this. And then I'll just cut and paste this into two lists. If you're writing it down, cutting and pasting is harder. But what you could do is just cross out wrapper and write two lists and return res, which is what I'm doing. Because here, what I'll do is just return str self to list, like so. Does that make sense?
So you're changing the wrapper.
So essentially wrapper used to create the list and then convert it to a string. And now I have a function that just converts the queue to a list.
Gotcha.
And in wrapper, I convert it to a list, and then I convert the list to a string.
Okay.
And that's because here, what I want to do is just convert self to list. and convert other to list. And just return L1 smaller than L2. I could also do a for loop, but Python actually allows me to just do this.
So I'm comparing the length.
No, it's comparing them lexicographically, right? So it says like, think about it as like dictionary order, where it says like L1 is smaller than L2 if the first element of L1 is smaller than the first element of L2, but if they're equal, then we compare the second and so on. So it's like words in a dictionary. Does that make sense? So, okay. So now that we have this, we can compare two circular cubes. So I'll push whatever, 11 and 12. And I'll print Q2. So let's see what that looks right now. Like right now, I need to quit Python here. Okay, so right now the first Q is 15, 17, and the second Q is 11, 12. And now if I want to be able to sort them, I could. This. And I'll just print the result. And here we are. Okay, so I think this looks like maybe kind of too easy. I don't know. Or like too hard and incomprehensible. But the basic idea is, in order to be able to sort objects, I need to have the LT function so that I can do, Q1 smaller than Q2, which I haven't actually done, but something like this. So this would be, so Q1, this would be false, right? Because Q1 is this and Q2 is this, so it's the other way, right? So in order to be able to say this, I need to have the LT function defined. So in order to do the LT function, what I did is I just made a custom toList function, and then I knew that I am actually able to just compare lists using Python. If I didn't know that, I would just write a custom thing, right? So I could say, go through the elements of L1, and if L1i is smaller than L2i at any point, then I'll return true. And if it's the other way, I'll return false. So think about it, like ordinarily, like one of those would be like this. So either L1 at 0 is smaller than L2 at 0, and then L1 comes before L2 in dictionary order, or the other way, and then not. Or neither of those, so that means that they're equal, so I'll just keep going. Right? So if I got to this point and they were all equal, that means that L2 is at least either equal to L1 or it's actually greater than L1 because it has extra elements at the end. So L1 starts with L2 and then L2 continues. So that would be false at this point. So I could also do just this. Yeah.
Just to clarify what the toList is doing, so you're taking it from a circular.
Yeah, so I've already converted them to just a list. Yeah.
Okay. So like if it started off So you like read it from start.
Oh, I don't even care about that anymore, right? Because I have my to list function, and the to
Right.
list function just converts them to an ordinary
It, like
list.
unfolds it, like it.
Yeah, exactly. Yeah. Right. So I think kind of probably most people the way they would solve it is like they would try to kind of play around with kind of the start and the end of both lists, which is maybe slightly more efficient, but harder. So here I just kind of wrap things into, okay, like I'll just convert it to a list and I don't anymore care that it's a circle, a queue, or anything else. Okay. All right. So this is this. And I guess now we are doing the same thing, except we are implementing it in C. Fun. So uh, uh, yeah, so I guess we'll do an H file. And so that's going to be like this. So we're just doing the same thing. We have the start, we have the end, we have the number of elements, and we have the so in C, I guess we would call it the array. So now we need to create it. We do circle queue. And we would want to destroy it. So I'll just copy and paste. One on queue. And one of these. Okay. So gonna implement all of that. So I'll just take this and copy to circular queue.c. So create, just copy and paste this. So I'll create a new one and then I'll assign it to star PCQ at the end. Stop me if it doesn't make sense. So this is the same as what's in Python, right? And then the array is just going to be size of ints. As I could also just say size because that's a local variable. So I'm sending in a pointer to circular Q star. And at the end, what they'll do is I'll just modify star PCQ so that I send in something that doesn't make sense and I set its value to CQ, which is this with all the variables kind of set appropriately. Does that make sense? Okay. So destroy would be just first destroy the array. And then free CQ as well. Is that good? Does that so kind of stop me if it doesn't make sense? So I guess one thing to ask is like, how would you call it? So the idea is you would say, okay, so circle Q, CQ over here, you just start it and then you create it, right? So that's the usual pattern, right? If you want to set CQ inside of another function, you need to send the address of it to the function. So that is why this is a pointer to a pointer, right? So we're sending in the address of CQ so that we can set CQ. And that means that the type must be circular Q star star. Right? And then in destroy, so in create, what we did is we malloced the array that's stored inside of circular Q. So the order in which we must do it is we must first free the array, because if we free CQ, we cannot anymore access CQ arrow array. Okay. So we have our unqueue. So that's going to be basically the same as in Python, right? So we'll check if the number of elements is the same as the size, in which case we're done. At this point, at least, we'll change it later. Otherwise, we just put the element at the end and we advance and to this. So that's exactly the same. The only difference is in Python, we were saying self because like this was basically self. Instead, we're saying CQ because we call it CQ. Like we could have named it self if we wanted to, but that's like not the convention in C. It's not happy about num elements is what we are calling it. Yeah, so we need to also update the number of elements. Like so. Okay. So DQ would be, again, the same as in C, as in Python, sorry. So here, I guess we didn't do it in Python, so I'm not going to do it in C either. So I'll just say CQ start, advance, and decrease the number of elements. So let's add a function that prints the Q so that we can kind of test it. Okay. Doesn't want to let me. Yes, so I think you did you want to are you typing everything in or are you okay? Let's take a break and except for you if you want to type it in. I mean, like if you're actually implementing it for use, then sure. Like how many errors you want to handle is kind of, you know. Yeah.
What is that little thing at the top if CQH isn't defined?
Yeah. So if you remember, like, so this is called the header guard. So the purpose here is that if we're including circular q.h in multiple C files, then if you don't do this, then it will try to basically read this in multiple times. And in C, you're not allowed to define the same thing twice, so it'll just crash. So this is basically just saying, like, if this symbol, which is not doing anything except being defined, if it's not defined yet, then define it and also read all of this in. If it's already defined, so that would mean that you're including circular q.h for the second time, then none of this actually happens.
Okay, so you only want to do it once.
Yeah, but that's like the only situation where we're always doing it in header files, and that's the only way that we're using the if not defined thing.
Because you can't include C files with other C
files. You shouldn't is more accurate, right? Okay. So like you can, but that creates problems. Okay. So like that. So like the way we do it is we define the H separately, where kind of where the declarations are, and then the definitions are in the C file. Okay. And that we only include the H, not the C.
Why do we have these like function in the?
So it's the same reason, right? So you cannot define the same function twice, but at the same time, if you want to use those functions in several different C files, then they need to be declared. So the way you do it is you include the H file, which says there's going to be a definition of this function somewhere.
Okay.
And then you just compile circular q.c once.
And then the other files are like, okay, well, we know that that's what that function is?
Like what it basically, yes. So what it is if the H is included, then it's like a promise that it's somewhere there.
Okay.
And then if you supply circle q.c as well, then it'll find the definition in there. But like, so that's like the real answer, but like we're only using it this way, right? So like we're always defining the structs and giving the declarations of the functions in the H,
Okay.
and then we're defining the function in the C. Like that's just the pattern.
And then, sorry, why is it that we use the double pointer for the circular Q create and nowhere else?
Right. So the reason is that when we are creating it, sorry, so for some reason it's not letting me click easily. Okay, so when we're creating it, the way we're calling it is like this, right? So we're saying we'll start with just CQ, which is a variable that can store an address, but currently isn't storing anything. And then we want to be able to change what CQ is to the actual circular queue. So that means that we must pass the address of CQ to create. Because at the end, what we're going to be saying is set the value at the address PCQ to the thing that we created, right? So we want to be able to modify this guy, which means that we must send this address, and the type of its address is ***. But that's not the situation with anything else, because with everything else, CQ, we're not changing the value of CQ. We're changing like CQ array and stuff, but we're not changing the value of CQ itself.
Okay, so when you want to change where something points, you have to have the double.
Not so much that. So if we want to change, so for anything, for integers as well, right? If I want to change the value of CQ,
yeah,
then I must pass the address of CQ.
Okay.
If what I want to do is actually just change the contents of so in Python, think about it as like, if I want to change the contents of a list, I can do that. But if I want to change, so in Python, it's like not at all possible to have like, a list L and then have a function that makes it so that L is a different list.
Yeah.
You can change the contents, which is what we're doing in on Q.
Yeah.
But you cannot change what it is, right? But here we must, because we start with CQ just being nothing, right? So CQ is just like some random number that's not a valid address.
Okay.
And then we want for the result of calling circular Q create to be that CQ is now a valid address.
Okay.
And the way we accomplish it is here we say *PCQ. So change the contents of this to this, which is the value that malloc gave us. So malloc gave us like a valid address, and we're wanting for CQ to be that valid address.
Okay, but in every other function, all you're doing is you're going to like size or
exactly. Yeah. So basically yes. So the only detail is we are actually like going to array and changing the data there, but that's fine, because array is just an address, and here the instruction is go to the address CQ array and then muck about at that address.
Okay.
But that's fine. Does that kind of make sense?
Yeah.
Okay. So like essentially, I think that the simplest way to think about it is, if you want to start with this and then you want for CQ to become a valid address, got to send in the address of CQ.
Okay. And for the array, it's like array is like CQ array is a pointer.
That's right.
Okay, so that's how you can do that.
That's right. So CQ stores an address that happens to be a valid address of an array.
Okay.
To which like we can go to that address and change stuff there.
Yeah.
But like CQ itself has the same CQ itself, like it already has the address. We're not changing CQ.
Yeah.
you might be changing like stuff inside CQ,
Okay.
but not CQ itself.
Which is, okay, okay,
Okay.
I got it, thank you.
All right. So that's DQ. And then we also want print. And here we'll do, so we have the same issue. So we'll say count is 0. All right, so this is counts. So that's the exact same idea, right? So we start with start, and then we print num elements of the elements. Let me do it as a space. And then at the end, I'll print a new line. Okay, so that's like exactly the same thing that we did in Python, right? So we start with CQ start, we keep going for num elements time, and we just print the element. Make sense? So okay. So now we want to use it. So that would be lab07.c, I guess. So, well, so I don't think you really, okay, that's like a little bit long. So we'll create the Q3, and I'll unqueue. So what did we unqueue here? And that doesn't matter. I'll unqueue like 11, and I'll unqueue 12. And I'll unqueue 13, just copy and paste, which you can do as well if you don't have Copilot. And then I'll dequeue. And then I'll unqueue 14. And now I'll print. So I need to open this folder. Level 7. in label7.c. I want the update. Favorite tasks. And here we want label 70C and we want circular QC and circular QC. And we're over here. Hopefully it works. Not sure what it's thinking. Yeah, okay. All right, so that should be printf. There's something underlined somewhere. So circular Q destroy here. This is like this, so this is good. I don't know what this problem is. Maybe nothing. Let me try to compile it. I'm not sure why my VS Code is hanging. I'll just try to restart it. Maybe it'll be faster. Oh, okay. It is not faster. I'm not sure what's okay. So here it is complaining. Oh, okay, so destroy, there's an int here. Oh, I see, because here I have int size and they should not have int size. It should be like this. So that is now fine. Yeah, sorry, it's hanging. I'm not sure why, but it's like either being really slow or just refusing. So I'll just run it like this. And it does print 12, 13, 14, which is what we want because 3 got dequeued. So I'm assuming you're typing stuff for this. So do you want me to pause or do you want me to scroll or like tell me what you? All right. All right. Yeah. think that's like a lot of people's plans for a lot of the components of this course. Okay, see ya, bye. Are you good?
Yeah.
Okay. All right. So the next part of the lab wants to deal with the situation where the queue is full. So if the queue is full, what you want to do potentially is make the array large, right? So the issue is basically like this. So if the queue looks kind of like this, so you like unqueue and then you unqueue this. So you cannot just say, okay, I'll just enlarge it and make it like this. Right? The reason you cannot do this is because this is not anymore a valid format, right? Because so the way the circular queue works is you want to say it goes from start to end, but now it used to be, for example, that the start was here, the end was here, but now you'll go here and there's nothing here. So what you want is when you're enlarging it, you actually want to move all of this stuff over here, right? So if the queue was like 71256, then the most efficient thing is to say, okay, don't care about this, don't care about this, and move the 56 over here. And now it's a valid circular queue. Okay. So that's what we'll do. So if the queue is full, so this is the queue being full, the first thing we'll do is we'll change the size of the array. And now what we want to do is we want to say, okay, so the start is still the start, right? But if it wraps around, then we want to move everything from here to here to the right. Does that make sense?
Like all the way to the right? Like,
Well, so basically, like if it went like this, so if it went like 71256,
mhm.
then what we want to do is we want to take the 56 and move it over here.
Yeah, okay.
All right. So let's do that. So basically it's if CQ end is smaller than CQ start, then that's an issue. And this is essentially, so this is like the for loop version of this, right? So move it to, so move the 5 to CQ size. This is still the old CQ size, plus 0, plus 1, and so on. Does that make sense?
What's the, when you're doing the realloc, what's the comma? CQ.
So this is the new size, right? So it used to be that this was the size, and now the size is twice what it used to be.
Wait. I guess I just forgot how realloc takes input. Wait, the parameters of realloc are
So
on the left, you know?
so the first parameter is just the old block, and the second parameter is the size of the new block.
Thank you.
All right. Okay. So once we're done with that, we just need to update the size and update the end. So I'll update the end first. So the end would just be the old end plus the old size, right? So basically we're saying the so we're saying, okay, like where would this end? It's like the old size is this much plus the old end, which was 1. So it would now end here. Okay. And then CQ size is whatever it used to be, but times 2. And that is it. So this is kind of the for loop version of this. You can also do it with mem move. So again, move to the end, move from the beginning, and move this many elements.
It feels a little redundant that you set the memory to like double the size and then you're like, oh wait.
Yeah, it's so it's because C doesn't actually record the size, right? So I have the pointer, but I also need to know what the size is.
Okay, there's no way of like combining those two. You just have to be like,
So, but I mean, so you could have like so you could have something like a Python list. So you could have, in fact, we did have like the array list where that's exactly what we had, right?
Yeah.
So we had like the pointer and then we had the data, but that would be custom.
Okay.
So by default, no. So like C tries to economize.
Okay.
That is it.
Wait, sorry, what are the parameters for mem move? So on the left?
So mem move is the destination,
Okay,
the source, and the number of bytes that you're copying.
Okay. Nice. Wait, sorry, so it's the index of the last.
So
Adding the size.
So this is just like how the math works out, right? So what we want to do is we want to move this part and And so this part means that end is 2.
Yeah.
Right? So we want to move, this part to over here.
Yeah.
So you move, so this is like the beginning of the new part of the array.
Yeah.
And then CQ end is because like CQ end here is 2, so like the index after the end. That means the number of elements that we want to copy.
Okay, smart. Yes, okay, so M.
Yeah. I think that's all of it, right? So the next lab solution session, so I announced tomorrow at 6. I actually had like a quasi commitment, as it turned out, for tomorrow at 6. So what I'll do is I'll ask on Piazza how many people would actually show up for tomorrow at 6. And if it's like fewer than 2, then I'll move it. So yes, I think like basically my plan is to just do so I have like a few days when I'm busy at 6, but I'll just like keep coming in at 6, or like myself or Samantha are gonna be like at 6 here every day, except on the weekends it's gonna be just on Zoom.
Oh, every day? Samantha said.
Yeah, so Samantha is doing right, and I'm doing the rest. Yeah.
Okay,
Yeah. Except like April 1st, I'm busy, but otherwise, yeah. Yeah.
thank you.
All right. But we do only have like 3 more labs. So we'll see. Like I like honestly, I don't know how many. Okay, so yeah. So I don't know how many people